Hello, I'm Papia. In this problem, we have to compute the derivative dy dx using logarithmic differentiation. So our expression, our function is right here, and in the right hand side the expression, there is a product and quotient of various functions. So instead of directly evaluating dy dx, sometimes it's a good idea to use natural log function, and then we use the logarithmic differentiation to compute the dy dx. So that's what we're going to do in this problem. The first thing you should notice is we have a domain given to us that x is greater than 2/3, and because of that this expression 3x minus 2 is going to be positive, which is what we want because there's a square root. We want the expression inside the square root to be positive. And if you notice the other expression, x squared, this is also going to be positive. Everything is going to be positive. So this entire y will be positive when x is greater than 2/3. And because of that, guess what? If we apply natural log to the function, it will be defined. So natural log of y is defined. And therefore, we can do that. We can apply natural log both sides and then take the derivative. Okay, so that's our first step. Take our equation, apply natural log both sides. Okay, so left hand side we will have natural log of y. Right hand side we have natural log of this entire expression. Now, why we applied natural log? Because we want to break up this big expression using properties of natural log. So notice that in the numerator we have x squared times the square root, and you're applying natural log. So remember the property, natural log will break them as sums. So you will get, for the numerator you will have natural log of x squared plus natural log of the square root 3x minus 2. And what happens to the one in the denominator? Well, you subtract, right? This is minus natural log of x plus 1 squared. Okay, is that it? Notice that we can go one more step. Natural log has the property that it brings down anything that's in the exponent. So natural log of x squared will become 2 natural log of x. Second expression, square root is actually in the exponent we have 1/2. This is 3x minus 2 to the power 1/2. So you bring down the 1/2 and you have natural log of 3x minus 2. And the last one also, you bring down the 2, you get 2 natural log x plus 1. Okay, so this is the most simplified form right now. Don't forget, left hand side we still have natural log of y. Okay, now we have to compute the derivative. So we do d dx both sides. Okay, so left hand side we have d dx of ln of y is equal to, you can take the derivative of each term separately, and since we know the constants will come out, let's just take them out already. So 2 times d dx of ln of x plus 1/2 d dx of ln 3x minus 2 minus 2 d dx of ln of x plus 1. Okay. let's compute each derivative separately. Okay, so the left one, be very careful. Look, you are taking the derivative with respect to x of the variable is y here, natural log of y. So you have to use chain rule. Okay, so first derivative of natural log is 1 over whatever is in there. So you get 1 over y times, you have to take the derivative of the y, which is y prime. So that's the left hand side. Now, right hand side, 2 times. Here, you're taking derivative of natural log of x with respect to x. So, same variable. Okay. So, ln of x, derivative is 1 over x. Next, 1/2 times. Again, notice here, it's not just natural log of x, it's natural log of some expression. So, chain rule again. First of all, outer function is natural log, its derivative is 1 over 3x minus 2. Then times, you take the derivative of 3x minus 2, which is 3. Finally, last term, negative 2 times. Same idea here. Outer function is natural log, its derivative is 1 over whatever is there, which is x plus 1, times, you do the chain rule, go inside, derivative of x plus 1 is 1. So, all the derivatives have been computed here. So, let's see what we have. We have y prime divided by y on the left side is equal to, we have 2 over x plus 1 over 2 times 3x minus 2 times the 3 on the top. So, it's 3 over minus 2 times 1 is 2 divided by x plus 1. Well, what are we trying to do? Don't forget, we are finding dy dx. Where is dy dx? It's right here, y prime. That's dy dx. So, all you have to do is multiply by y on the right hand side and you are done. And you just have to rewrite what y is because we want our answer to be in terms of x in the end. Okay? But before I do that, let's combine these 3 terms together, okay, with a common denominator. And then we will multiply by y later. Okay, so common denominator addition. You see that there are 3 different factors and you can just multiply them all. So we have x times 2, 3x minus 2 times x plus 1. Okay, in the numerator, for the first term, 2, you remember how to do the common denominator addition, right? So you keep the 2. See, the 2 is already attached to the x, so you cover up the x and whatever is remaining, you multiply that whole thing with 2. So 2 will get multiplied to 2 times 3x minus 2 times x plus 1. And you keep on doing for the other terms. So next, we have plus 3 times, you get rid of this portion, 3x minus 2 and the 2, and multiply x times x plus 1. Finally, negative 2 times, you get rid of x plus 1 and multiply it by 2x times 3x minus 2. So let's simplify the numerator next. Okay, so let's see. From the first term, 2 times 2, we have 4. Okay, let's multiply, let's FOIL these 2 factors here. So 3x times x, we have 3x squared. Next, you see 3x times 1, 3x, minus 2 times x minus 2x. So 3x minus 2x will be plus x. Negative 2 times 1 is minus 2. Next, we have 3x times x, so 3x squared, and 3x times 1 plus 3x. Next, we have this is 2 times 2, 4x times the entire thing. So let's multiply it. So minus 4 times 3, 12x squared, plus, because there are two negatives, plus 4 times 2, that's 8x. Okay, denominator we have 2x, 3x minus 2, x plus 1. Let's distribute this 4 and let's see if anything cancels out or if we can find common terms that we can group together. Okay, so we get 4 times 3, 12x squared, plus 4x minus 8, and then we have this remaining plus 3x squared plus 3x minus 12x squared plus 8x, and denominator remains the same. Okay, anything cancels? Yes, the 12x squared and minus 12x squared, I see one of them cancels. What else? Nothing else, but we can combine some things. Right, so let's move up here. Remember the left hand side, we still have y prime over y, and this is the right hand side that we're working with. So we have 3x squared, then we have 4x plus 3x, that's 7x, plus 8x, so that's 15x, and we have a constant negative 8, and denominator 2x times 3x minus 2 times x plus 1. Okay, so notice we have simplified the numerator completely. We have these factors in the denominator. To finish the problem, all we have to do is take this y to the right hand side and we will have dy dx. So y prime is equal to y times this entire right hand expression. 3x squared plus 15x minus 8 divided by 2x, 3x minus 2, x plus 1. Now, like I said before, do not leave the answer this way, because notice at the very beginning, the function that was given to us was in explicit form. Y was a function of x. So when you compute dy dx, you should have everything in terms of x on the right hand side. So all you have to do is plug in what is y. That is the very first function that's given to you. Okay, so plug in y. Y was x squared times square root 3x minus 2 divided by x plus 1 square. And that is multiplied to the expression 3x squared plus 15x minus 8 divided by 2x times 3x minus 2 times x plus 1. Now, before you finish and before you write down your answer, let's see, is there anything that we can cancel when you plugged in y? Notice that we have x squared and we have an x in the denominator. So you can cancel one of the x. Also the 3x minus 2 factor. There's a square root and you have to the power 1 in the denominator. So you can cancel part of that as well. So let's write down the answer now. In the numerator, I will have 3x squared plus 15x minus 8. Denominator, times x in the numerator. There's another extra x there. Okay. Now, if you cancel 3x minus 2, those terms, you will get a square root of 3x minus 2 in the denominator. And you can combine the x plus 1 terms together. There are two of them and one here. So that will be x plus 1 cubed. and you also have a constant 2. So this is dy dx. Thank you.